I'm Sandhya, Department of Mathematics. In this class, we are going to see about the continuous random variable. So, in this previous class, we saw what is random variable and discrete random variable. So, today we are going to see what is continuous random variable. So, in this continuous random variable is denoted as probability density function. So, every f of x greater than or equal to 0 and integral minus infinity to infinity f of x value is equal to 1. This is the continuous random variable. So in this manner we are going to see some basic problems for the continuous random variable. Okay, so in this so see the problem, a continuous random variable x has probability density function. So if it is a discrete, it is a probability mass function. So the given one is f of x equal to k. So we have to find the constant. Okay, so here the range is given. What is the range? The range is 0 to 1. So find the k and p of x less than or equal to 1 by 4. So first we have to find the constant and then we have to find the p of capital X less than or equal to 1 by 4. So we have to find the constant is minus infinity to infinity f of x into dx equal to 1. We are operating both left hand side and right hand side also. So here the f of x value is k. So the range is lies between 0 to 1. So the upper limit is 1 and the lower limit is 0, k into dx. Okay, so here after integrating, so here k is a constant outside, take it outside, 0 to 1. So dx equal to 1. So the integral of x dx is x. So k 0 to 1 equal to 1. So the k value is 1 minus 0 equal to 1. So k equal to 1. So this is the k value. So here the f of x value is 1 into dx. The range lies between 0 to 1. Next we have to find the p of x less than or equal to 1 by 4. So in this 1 by 4, okay, so here the range is general limit is, so here see, so here 0 to 1, here f of x is lies, okay, that is k. In our condition is the 1 by 4 is occurring here, okay, so it is what is f p of x less than or equal to 1 by 4. So we using the range is 0 to, so this is the lower limit, 0 is a lower limit, 1 by 4 is the upper limit. Here see 0 and 1 by 4. So k is a 1, so take it outside, so 1 into dx. So after integrating and then substitute the range, so the answer is 1 by 4 minus 0. So the value is 1 by 4. Okay, next we want to see the another problem. So in this problem, test whether, so we have to check it is a probability density function, given condition is a probability density function or not. So here the f of x is given, e power minus x greater than 0 can be probability density function of the continuous random variable. So here we want to checking the two condition. What are the two condition? First one is f of x value is greater than or equal to 0. Next one, minus infinity to infinity f of x into dx is equal to 1. So taking left hand side and then prove the value of that is 1. So if it is 1, so the probability density function is given condition is a probability density function, otherwise it is not a probability density function. Okay, so here minus infinity to infinity f of x into dx, here also we taking x greater than 0. So in this line, so see in this line a common line is minus, this is the minus infinity to infinity 0. Here our x greater than 0, so this is the lower limit and this is the upper limit. For this problem we taking f of x equal to e power minus x. Okay, so here see minus infinity to infinity f of x into dx equal to minus that is 0 to infinity e power minus x into dx. After the integration with respect to x, e power minus x into minus 1. So the denominator, so the value is minus e power minus x. 0 to infinity we have to substituting the upper limit minus lower limit. E power minus infinity value is 0, e power 0 value is 1. So upper limit minus lower limit. Okay, so here the minus and the problem on minus, the minus into minus is plus, so equal to 1. So yeah, minus infinity to infinity f of x and dx equal to 1. So it is a probability, given condition is a probability density function. Next we are going to see some another problem. A continuous random variable f of x is 2x 0, x varies from 0 to 1, otherwise it is probability density function. So given condition is a probability density function, so we don't want to check it is a probability density function or not. Here we want to find some conditions is given. So p of capital X less than 1 by 2 and x varies from 1 by 4 to 1 by 2 and x value is greater than 3 by 4 given x greater than 1 by 2. So here the probability, that is conditional probability, is given. So here the general thing is 0 to 1 by 2. So here the range is 0 to 1 by 2. First in our question is 1 by 2 is occur, so x less than 1 by 2. So we taking 0 is a lower limit and 1 by 2 is a upper limit. Okay, so here see, okay, so 0 to 1 by 2 into dx and 2x into dx. So after integrating the value is 1 by 4. Next we want to check another one. So this is the upper limit. So here see 0 1, so 1 by 4 here. Okay, 1 by 2. So upper limit is 1 by 4, the lower limit is 1 by 4 and upper limit is 1 by 2. See, okay, so after integrating we get the value of 3 by 16. Another, the conditional probability is given. So you know the conditional probability. What is the conditional probability? P of A given B equal to P of A intersection B divided by P of B. So using this formula we have to find this condition. Okay, so see, so A intersection B. So in this portion the intersection is P of x greater than 3 by 4 and P of x greater than 1 by 2. After integrating the final answer is 1 minus 9 by 16 and 1 minus 1 by 4. So the final one is, what is that, 7 divided by 12. Okay, so these are the final answer. Thank you.